Welcome everyone to a session on automata theory and computability. In today's session, let us learn how to design a NFA for some simple regular languages. Okay, we'll start with the first one. As displayed on the screen, the language L says it is made up of string 0 and 1, and the definition of language accepts all the strings ending with 0. Okay, so I should start with Q0. Okay, when will I accept the string? The string that ends with 0. Okay, if the string is ending with 0, I'll go to some accepting state and let me name this as Q1. Okay, now if a string ends with 0, then I'll go to Q1, right? So any more after I get the 0, that I shouldn't have any transition from Q1 state, right? So I'll go to Q1 state from Q0 only if I encounter 0 at the end, right? Now what about the remaining part of the string? What if I get any combination of zeros and 1 before I go to Q1? So I should have a self loop from Q0 to itself upon 0 to 0 or 1. Okay, so upon 0, Q0 upon 0, I have multiple transitions. So one transition will remain in Q0 itself, and I'll go to Q1 state only if I encounter the 0 as a last symbol in my string or last character in my string. Okay, so let us see whether this works or not. We'll take some simple example. Okay, 1 1 0 0 1 0. Okay, we'll consider this. Let us see whether a string accepts the transition diagram accepts the string or not. Okay, we'll start with Q0, and Q0 upon 1, I have only one transition, so I'll go to Q0 itself. Then I encounter one more one, so I'll remain in Q0. Now I get the 0, so Q0 upon 0, I have two transitions. In one, I'll remain in Q0 itself. The other one, I'll go to Q1. Okay. Now, being in Q0, I have encountered one more 0, right? So this is for the second 0 in my string. So Q0 upon 0, again I'll go to Q0 or I'll come to Q1, and Q1 upon 0, I don't have any transition. There is no definition for Q1 upon 0, so I'll go to some dead state, dead configuration. Okay, so this is the dead path. I cannot continue further from null. Okay, so till second 0 we are done. Now we encounter 1. So Q1 upon Q0 upon 1, I'll remain in Q0. Q1 upon 1, I don't have a transition, so I'll go to dead path, dead state is represented with null. Now I encounter 0. So upon Q0 upon 0, either I'll go to Q0 or I'll come to Q1. So did I reach the end of the string? End of the string is reached. Now by encountering all the characters in the string, at the end we have ended up in Q0 or two states, right? Q0 or Q1. So the non-deterministic path has ended up in either Q0 or Q1. Now, do I have any one among this? Do I have any accepting state? Yes, Q1 is the accepting state. So my string is totally valid and it should be accepted. Okay, so our NFA works perfectly fine for all the valid string and rejects all the invalid string. We'll see one more. Consider this problem. Here the language L is made up of string W from the alphabet set A, B and C, and the definition says string contains substring ABC, ABB. Okay, so if a string contains ABC, ABB as a substring, then those strings should be accepted. Okay, and design of NFA for such kind of problem is very simple. We'll see. So we'll start with Q0, and Q0 upon A, I'll go to Q1. Q1 upon B, I'll go to Q2, Q2 upon C, I'll go to Q3, Q3 upon A, I'll go to Q4, Q4 upon B, I should go to Q5, and Q5 upon B, I should go to Q6, which should be marked as accepting. Okay, so this will accept uh, a string that contains ABC, ABB as a substring, but we are not done. So this ABC, ABB can be occurring at the beginning or at the end or in between, right? So what if I have many different sequence of A, B, and C before I encounter this substring? So what should we do? We should have a self loop upon Q0 for A, B, or C, and once I get this substring, whatever comes further, that should be handled in Q6 itself, right? Yeah. So this is the solution for a problem that says contains a substring ABC, ABB. Okay. Now let us consider few problems that can be solved with the help of epsilon transition. Okay. So let us see the first one. Here the language says string is made up from AB, and W is made up of optional A followed by AA followed by 0 or more B's. Okay. So first let us analyze the question. So here W is made up of optional A. So this first A is optional, right, according to the question. Then it is followed by two A's. So this is optional. I'll put a box around it, followed by two A's, followed by 0 or more occurrences of B's. So I can have any number of B's, right, or I can have 0 B also, right. Okay, now we have to design a NFA for this particular problem. Okay, so while designing, let us first consider A not as an option but as a part of the string. Okay, so if A is not an option, if it is part of the string, then I should have 3 A's followed by any number of B's, right? So Q0 upon A, this for the first A, which is asked as optional, shall go to Q1. Then Q1 upon A, I should go to Q2. Then upon Q2 upon A, I should go to Q3. Now I have reached Q3. Once I reach Q3, then I can have any number of B's, right? So I can have 0 B also. So what should I do? I should mark Q3 as the accepting state, and Q3 can have any number of B's, right? Okay, so this solution is perfectly fine if the first A is not made as optional, right? Now the question clearly says the first A can be optional. So we should also accept a string that starts from AA followed by any number of B's, right? So somehow I should be able to handle this problem, right, or this criteria. So what I can do? Somehow I have to go to Q1, isn't it, by not encountering A. So that can be done by having an epsilon transition from Q0 to Q1, and the transition upon what symbol I have to mark epsilon, right? So if this is the case, what will happen is from Q0 I can virtually start scanning from Q0, or I can start with Q1, because from Q0 by not encountering anything I can directly jump to Q1, or I can go to Q1 by encountering A, right. So this, in this case, I have made A as optional, right. So I can come to Q1 either by scanning A or by not scanning A, which is written in terms of epsilon, right. Now let us check whether AAA followed by any number of B's will be accepted or not. Okay. So what do we have? Q0 upon A. So I'll come to Q1. Q1 upon A, I'll go to Q2. Q2 upon A, I'll go to Q3, followed by any number of B's. So this string is totally accepted, right? Now in case of if I consider AA followed by 1B, then according to the question, even this is fine, right? So how to solve a problem? So of course, NDFSM takes multiple paths, and one of the paths will start from Q1, isn't it? So what do I have before this A? I have nothing, right? And how can I represent nothing? I can represent nothing as epsilon. So Q0, from Q0, I will directly jump to Q1 by not encountering anything. Okay, so then from Q1 I'll encounter A, and I'll go to Q2, and Q2 I'll encounter A, so I'll go to Q3, and Q3 I will encounter the B. Now, did I end up in accepting state? Yes, right. So one of the path will lead me to the accepting state. So this is how I can solve such kind of problems by having an epsilon transition. Okay, we'll consider a few more. Now let us consider some problems which has many multiple sub languages. Okay, so here L is a language which made up of string W from the alphabet set AB, and um, see, W can be ABA, or the length of W is even. So what I have is, I have two different sub languages under a common name L. Okay, so I have option R, right? So W can be either ABA or W is even. So this can be solved with NFA, by making use of NFA with the help of epsilon transition. So such kind of language should have two different starting points. Okay, one for each sub language. Okay, I'll name Q1 and Q2. So with respect to Q1, let us consider Q1 as the virtual starting point for ABA, and Q2 for W, length of W is even. Okay, so Q1 upon A, I'll go to Q3, then Q3 upon B will go to Q4, and Q4 upon A, I should go to some accepting state, and let me name it as Q5. Okay, so this will solve the problem of one part of the question, that is W is equal to ABA. Okay, now what about the other one? Other one says length of W is even. Okay, so Q2 upon, okay, so what is the minimum length for any string to be considered as even? Epsilon, right? So I should mark Q2 itself as accepting state, and if I get either A or B, then the length becomes odd. I should go to Q6, which is non-accepting, and being in Q6, if I get either A or B, then the length becomes even, so I should go back to Q2, right? So this will solve the problem of the second part of the question, that is the length of W is even, right? Now somehow from Q0, the actual starting state is Q0, right? Now how can I have a virtual start from both Q1 and Q2? That is done by having an epsilon transition from Q0. Okay, so Q0 upon epsilon, I'll remain in Q0, will go to Q1, or I'll go to Q2, right? Now if I have a string something like ABA, right, what will happen? From Q0, before A I have epsilon, so I will start either from Q1. No, one path will start from Q1, and the another path will start from Q2. Okay, so Q1 upon A, I'll go to Q3. Q3 upon B, I'll go to Q4, and Q4 upon A again, I'll end up in Q5. So one path will end up in Q5, and the other path, okay, other path um, will start from Q2, and Q2 upon A, I'll go to Q6. Q6 upon B, I'll go to Q2 again, and Q2 upon A again, I'll go to Q6, right? So one path will end up in Q5, and the other path will end up in Q6. So do I have an accepting state here? Yes, right? Q5 is the accepting state, so my string is accepted. Okay, what if I have AA? So will this be accepted? Yes, let us see. So one path, I'll start from Q1 because I have an epsilon transition, and another path I will start from Q2, right? So Q1 upon A, I'll go to Q3, and Q3 upon A, I don't have a transition, so I'll go to some dead path. Okay, so that path is over. Now Q2 upon A, I'll go to Q6, and Q6 upon A, I'll end up in Q2, which is the accepting state, right? So for AA, either I'll end up in null, which is the dead path, because I don't have a definition for A upon Q3, or I'll end up in Q2. So is this accepted? Yes, because one of this is a accepting state, right? So this is how, with the help of epsilon transition, I can solve problems that involves multiple sub languages under a same language, right? We'll see a few more. Okay, let us consider this problem. Here the language L is made up of string W from the alphabet set AB, and the definition says the fourth from the last character is A. Okay, so this means the fourth character from the end of the string should be A. Okay, so what is the minimum number of characters required in the string? It should be 4, right? The minimum length of the string should be 4, and the fourth character from the end should be A, and we are not bothered about the previous characters or the last 3 characters. It can be anything, right? That is not given in the question. Okay, so how many states do I require? I require 5 states to have a transition of 4 characters. Okay, so here I can have 3, 2, 3. Okay, one more state. Okay, so I'll mark this as the accepting one. And what can be the first character from the end? It can be anything, right? So it should be marked as either A or B. So what can be the previous one? Even that can be anything. We are not bothered about the whether it is A or B, right? Because it is not asked in the question. What about the previous one, third character? Even that can be anything, right? But what about the fourth character from the end? So according to the question, it has to be A. So I can have only A, right? So I can go to some accepting state only if I encounter A as the fourth character from the end, right? Okay. Now, what can be the previous characters? So this is for minimum length 4, but they have not asked anything like the number of characters. They have not restricted the length of the string, so it can be anything, right? So if I have any sequence of characters before the fourth character from the end, I should have a self loop, right? Okay. Now I have to name this Q0, Q1, Q2, Q3, Q4, right? Okay. So let us take one example. If I have A, B, A, B. So what is the fourth character from the end? It is A, right? Now one of the path. So let us see what happens. Q0 upon A, either I'll remain in Q0 or I'll go to Q1. So let us consider one path which will take me to the accepting state. Q0 upon A, I'll go to Q1. Q1 upon A, I'll go to Q2. Q2 upon A, I'll go to Q3. And Q3 upon A, I'll end up in Q4. So this will be valid. So one path will lead me to Q4. So this will be accepted, right? Okay. Now, what if I have any number of characters? So will this be accepted? Yes. So this will also be accepted because one path, in one path, I'll remain in Q0 up to AABB. Then I'll continue for A. I'll go to Q1, and for the next 3 characters, I'll end up in Q4. So I am talking about only one path. Of course, there will be multiple paths in NFA. So this path upon Q, yeah. So if I go to A, then this will be accepted, right? We'll consider one more problem for the session, a very interesting problem. Okay, here L alphabet set is made up of A, B, C and D, and the language L missing says it is made up of string W, and there is a symbol A of I that belongs to the alphabet set not appearing in W. So in a very simple word, what the language says is it should accept a string that should have at least one of the symbols to be missing in the string. Okay, so either I can have all the 4 characters to be missing, or I can have A missing, B missing, C missing, or D missing in my string. Okay, or I can have any combination of 2 symbols or 3 symbols that is missing. But only thing that shouldn't be accepted is all the string appearing in the string A, B, C, and D. Okay. Now, yeah, how to start a solution? What we can do is, okay, what is the simplest string that is accepted? Epsilon itself, right? Because it will have all the 4 characters to be missing. So Q0 should be marked as accepting. Now what about either one of the character missing? So I can have string either A missing, B missing, C or D missing, right? So what I have to do is I need to have 4 different states, okay, each representing one of the characters to be missing in it. Okay, okay, so Q1 represent a state which is having missing A. Q2 will be represented for missing B, Q3 for missing C, and finally Q4 for missing D. And all this should be marked as accepting because they are missing at least one of the characters, right? Here Q1 is missing A, Q2 missing B, Q3 missing C, and Q4 missing D, right? Now what transition I can have for Q1? I should have a self loop in Q1 upon encountering B, C or D, right? Because A shouldn't be there because A should be missing in it, right? Similarly for Q2, I can have a self loop for A, C or D, and self loop for Q3 upon A, B and D, and self loop for Q4 upon A, B and C, okay, where D is missing. Okay, and I should have a virtual start from all these states. So I should have a epsilon transition from Q0 to these states, right? Okay. So this is the solution. Let us see whether our solution works or not. Okay. What if the string itself is epsilon? So I have no string at all. Now, upon encountering epsilon in Q0, which are the states I will end up in? I will end up in, so either I will remain in Q0 itself, or I can go to Q1, Q2, Q3 or Q4. So this is my final set, right? And do I have an accepting state here? Or actually I have more than one accepting state. All 5 are accepting states, right? So my string epsilon is accepted, right? Okay. Now what about single A? So if I encounter A, so I can have a virtual start from Q1, Q2, Q3 and Q4, right? So A upon Q1 upon A, I don't have a transition, so there is no definition. So I'll go to some. So for this, upon Q1, I'll go to some dead path. Q2, I will, yeah, I will remain in Q2 itself. Q3, I'll remain in Q3. I mean Q3 upon A, I'll remain in Q3. Q4 upon A, I'll remain in Q4. Okay. So at the end, this is what I end up, right? So do I have an accepting state here? Yes, I have 3 accepting states. So this will be accepted because in the string A, I have B, C and D missing, right? Which satisfies the condition of according to the definition of the language, right? Okay. Let us take a few more. Okay. What if I encounter ABC? So let us check whether the string will be accepted. Okay. So I have ABC. Of course, D is missing. So we will have a virtual start from Q1, Q2, Q3 and Q4. Q1 upon A, I don't have a transition, so I'll go to some dead path. Q2 upon Q2 upon A, I have a self loop, and Q2 upon B, I don't have a transition, so I'll go to some dead path. Q3 upon A, I'll remain in Q3. Q3 upon B, I'll remain in Q3. Q3 upon C, I don't have a definition, so I'll go to some dead path. Now Q4 upon A, I'll remain in Q4. Q4 upon B, I'll remain in Q4. Q4 upon C, I'll remain in Q4. So at the end of ABC, I'll remain in Q4. And what are the various other paths? Those are dead paths from Q1, Q2, Q3 and Q4, right? So my string has one accepting state, so this will be accepted. Now what if I have A, B, C and D, right? What will be the transition? Yeah, this should be rejected because I have all the 4 characters appearing, right? So what will happen? Q1 upon A, I will go to some dead path, so I cannot continue in Q1. Q2 upon A, I will remain in Q2, but then I'll encounter B, so I'll go to some dead path. Q3 upon A and B, I'll remain in Q3, then I'll encounter C, so I'll go to some dead path. Q4 upon A, B, C, for the first 3 characters, I'll remain in Q4, but then I'll encounter D, so then again I'll go to some dead path, right? So I'll go to some dead paths from all the 4 states Q1, Q2, Q3 and Q4. So do I have some accepting string? No. I mean accepting state? No. At the end I will not have a end up in any one of the accepting states. So this A, B, C, D will be rejected. Okay. So this is about NFA. I'll see you in the next one.